All right, we're going to pick up in Unit 1, Section 4, still reviewing algebra ideas. We're going to solve systems by substitution this time. We just finished solving by graphing. Now we're going to solve by substitution. So I will be able to, every time, I always forget the pen. Solve systems by graphing. In my very bad handwriting. That's an R, that's an A, I promise. All right, so let's look. First, we're just going to solve equations. Refresh our memory on that. Solving equations means get the variable by itself, everything else on the other side. So we're going to look for x first here, and 3x plus 16 equals negative 5. Start outside, work your way in. When you're solving, you're reversing PEMDAS, SADMAP. You're going to add, subtract away, multiply, divide away, exponent away, parentheses away. When you simplify, you do inside out. Go on the most inside piece, work your way out. This one we're doing the other way. I'm adding 16, I don't want to, so I'm going to get rid of that. 3x equals, they're both negative, so it's going to get more negative, 21. What's happening is I'm multiplying by 3, so to get rid of it, I divide by 3. It turns to 1, so x equals negative 7. Try the one to the right here. X minus 27 equals 7x minus 15. Remember, there's always more than one way to solve. You may end up with the x on the right and the number on the left, or you may end up with the x on the left and the number on the right. Both are still good as long as you get the right x. So pause it right here, try the one on the right, and then come back. Okay, here we go. This is how I'm going to do it. I'm going to subtract 1x and leave it negative 27 equals 6x minus 15, because I want my x to stay positive. I'm going to add 15. That's supposed to be a 15, not an 8. Make sure you write the right number down. All right, those are opposite signs, so they're going to take away from each other. I'm going to end up negative because the 27 is bigger. 7 minus 5 is 2. 2 minus 1 is 12. Where did I write that? So 12. Good. It divides by 6. So negative 2 equals x. Should have got negative 2. All right, I'll do a demo here with the parentheses inside. We should do the parentheses first when we look inside them, simplifying wise. There's nothing you can do because this one's an x and that one's a 9. So we're going to get that out of there. This is actually a negative 1, and it's next to the parentheses, so we have to distribute. So 6x stays, becomes negative 2x when I multiply here. And then when I go to the negative 9, negative and negative makes positive. 1 times 9 is 9. Negative 31. 6x minus 2x, those are like terms. Gives me 4x plus 9 equals negative 31. I'm going to minus 9 here. 4x equals negative 40. Divide by 4. X equals negative 10. Okay. I'll switch to blue so you can see the difference. But go ahead and give this set over here a try first. Give it a pause, come back and see how to work it. Okay, here we go. Distribute first. So 2x stays, 8x. 8 times x is 8x. 8 times 3 is 24. 3 times x is 3x. 3 times negative 13 is negative 39. 2x and 8x is 10x plus 24 equals 3x minus 39. I'm going to move my 3x to this side because that'll stay positive. Makes me 7x plus 24 equals negative 39. 2. Move the 24. They're both negative, so it's going to get more negative. All right, so 4 and 9 makes 13. 1, 2, 3, 4, 5, 63. Divided by 7. X equals negative 9. So that's solving just for x. Now, when we get into solving systems, we've got 2 variables. You can't solve 2 variables with 1 equation. You need to solve with 2 equations, okay? Because you have to solve for 2 different variables. When we did it graphing, we can solve for each variable kind of at the same time because the coordinate we see tells us exactly where they meet. But when we do it algebraically, we're only going to get to see one letter at a time. So This is a method of solving systems of equations by substituting. What do we mean by substituting? Well, substituting means that we replace one thing with something else that is equal to that thing. Okay, so substituting one equation into another equation. So we're going to have to figure out what one of the variables is by itself. Then whatever it equals, we can plug in for that variable. And then we can solve like we just solved these guys because we only have one kind of variable in the equation at a time. So look for an equation that is solved for x or y. Substitution, the only time I really do it is if one of the equations they give me already says y equals all of that stuff over there, or x equals all of that stuff over there. Or it's a really easy move. I got one move and then the one variable's by itself. You're going to substitute the expression into the other equation for the variable that you have solved. Then you're going to solve it for the variable that is left. Then you're going to substitute your answer into the either, but I like to go with the other, the equation you didn't just work with, and find the other variable's solution. And then you're going to write your answer as an ordered pair. Okay? Really, it would be like x equals this and y equals that, and then we can put them in a parenthesis together. So let's go ahead and see how that works. All right, we've got y equals x minus 9, and we've got y equals 4x minus 24. So let's switch back to red just because I like the way it looks. This equation equals y. That equation equals y. So that means that I can plug this whole thing into that equation for that spot. Because if y is equal to 4x minus 24, then I can put a 4x minus 24 anywhere I have a y. So that's exactly what I'm going to do. I'm going to put 4x minus 24 on this side and then leave the x minus 9 on that side. Now I'm going to solve for x. Minus the x. 3x minus 24 equals negative 9. Add 24. 3x equals, we got to go 9 down from 24. That's going to get very interesting. Okay, so let's see. If we went down 10, it'd be 14. So 9 is going to be 15. Oh, that's nice. It divides by 3. Perfect. Goes to 1. X equals 5. All right, so in our ordered pair, we know the x part is 5, but what we don't know is the y part. So what we do is we go plug it back into one of the equations. Doesn't matter which, I'm going to pick the one that has the least amount of work to do, the one with just one x. So y, actually I'm going to switch colors, undo. This is our substitution part. Now that we know that x is equal to 5, go away. In this equation, where x used to be, right, that was my x, I'm going to plug in 5. And so 5 minus 9 is negative 4. I know the y part. It's negative 4. It's that easy. Substitute one for the other. We could even check our answer graphically if we wanted to. Pull up Desmos here. Got a lot of equations on it already. We can say y equals x minus 9. And let's go back home. And we could say y equals 4x minus 24. And they touch at 5, negative 4. So you could solve them by graphing when you got that graphing calculator, but if you don't have graph paper and you don't have the graphing calculator, I like to do them substitution style. Okay, so here I know y is equal to this piece right there, so I can say negative 5x equal, nope, not equals, plus 11 is equal to negative 8x plus 14. I'm going to add 8x. That'll make the x positive. Gives me 3x plus 11 equals, I'm just going to put 14 because it's positive, minus 11. 3x equals 3. There we go. Make the math right. Divide by 3. X equals 1. So I know 1 comma something. And I'm going to plug it back in. Now 1 times anything is pretty easy, so it doesn't matter which one I plug it in for. So y equals negative 8 times 1 plus 14. Y equals negative 8 plus 14. And y equals, difference there would be 6. Now, I should be able to plug it in the other equation, and it has to make it true. We talked about that last section. If it is a solution to the system, it must make both equations true. So if I plugged in, let's say, -5 times 1, it needs to equal a 6 plus 11. 6 equals -5 plus 11, so 6 equals 6. Why, yes it does. So definitely the right answer. Now, this equation is a little different. When I look at both of them, the top one, that equation is not set up so that one of the variables equals all of the stuff on the other side. I've got -5x plus 4y equals 7. That's standard form. ax plus by equals c. But the y is right here, and I know what y is equal to, so I can plug all of this stuff in right there. So -5x plus 4 times something, and what I'm going to plug in is all of this stuff into there, -2x minus 8, because I'm substituting where the y used to be, right behind the 4, and I'm plugging in what it is equal to. So then I've got -5x. Now, 4 times -2x is -8x, and 4 times -8 is -32, and it was a 7 on that side. These are both negative, so that's -13x minus 32 equals 7. Add 32 to both sides to get rid of that. -13x equals 39. Oh, that's good. -13, x equals a -3. So -3 is the x part. Now we need the y part. Which one's easy to solve for y? The one that says y equals, all right? Y equals -2 times -3. I plug it in for the x. Y equals -6 minus 8. So y equals -14. And we substitute it. Substitution style is going to have 2 substitutions in it. First, you plug in the entire expression that one letter is equal to into the other equation. Then when you figure out what that variable you solve for is, you're going to substitute that into one of the equations and get the other variable. Okay. So here in the second, I'll let you try. Give it a pause, see what you get. Okay, here we go. First equation is solved for a variable, so I'm going to plug that in right there. -3 times, and then I got -4y equals 13. Okay, so all I'm doing is I'm taking this piece, and then right in here, I'm going to substitute, and it's equal to this whole thing. So I'm going to take -4y minus 23, and I'm going to just bloop, plop it in right there. So then I distribute. -3 times -4 is 12y, positive. -3 times -23 is going to be positive. Let's see, 3 times 20 is 60, and 3 times 3 is 9. 69 minus 4y equals 13. 12y minus 4y is 8y plus 69 equals 13. Minus 69, that's a row to 66, that's not what I wanted. Minus 69, 8y equals a negative number. Got to go down 13, down 10 would be 59, and down 3 would be 56, so good, that divides by 8. So y equals -7. Now I got to be careful when I write my parentheses this time, right? Freaking messiness. It's the y part, not the x part. Now we're going to plug in -7. I'm going to leave x equals -4 times something minus 23. And I'm going to take that -7 and plug it in right there. Okay, I'm drawing the arrows to show you where I'm going. X equals 28 minus 23. So x equals 5. And we do that. We could check our answer and plug it back in. -3 times 5 is -15, plus 28, so -15 and 28 would be 13, and 13 equals 13, so checks out. Very, very good. All right, these are my favorite. We already know part of the answer. Look at that, y equals -4. Okay, so if I'm going to do my parenthesis, the y part's -4. Remember, that's a graph. If we were to graph that, we go 1, 2, 3, 4 down, and y is going to be -4. So then all we have to do is plug it in. 3x minus 5 times something equals 23, and I'm just going to take that -4 and plug her in. 3x plus 20 equals 23. Subtract 20. 3x equals 3. Divide by 3. X equals 1. Nice and short, easy peasy. These are the kind of problems that I usually do substitution for. I don't normally substitute whenever the other ones go. I do what we're going to learn in the next section, which is called elimination. But if one letter is ready to go and the other equation is not, take that letter, plug it in, figure it out. Okay, give it a pause. Try the one down here on the bottom. Okay, here we go. We already know x. X is -3. We just need the y. So 4 times something minus 9y equals -48. And we're going to take that -3 and plug it in right here. I'm already doing the math. My bad. 4 times -3 is -12 minus 9y equals -48. Add 12. 9y equals -36. Divide by 9y. Divide them by 9, not 9y. Leave the y. Negative makes positive. 36 divided by 9, 4. Boom. Algebra skills, man. That's why we do algebra before we do geometry. All right, we're back to some standard pieces that have one solved and one doesn't. Go ahead and give it a pause, give them a try, and let's see what you get. Good. Now remember, we have 3 kinds of answers. You've got intersecting lines. That's one solution, right? X comma y. We've got parallel lines that have same slopes but different y-intercepts. That's no solution. And then you have same lines. That's infinity solutions. Okay? Well, this one's in y equals mx plus b. So if we rearrange the other one, we might see something neat happen, but let's see what happens algebraically whenever we do the math here. Okay? Remember, solutions have to make equations true. Like whenever we substitute it back in and we got 6 equals 6. So let's see what happens. We know y is this much. We know y goes right here. So let's say -x minus some big thing equals 1. And we're going to plug in -x plus 4. That's a -1 actually. So let's distribute. -x plus x minus 4 equals 1. -x and positive x, that goes to 0. So we got -4 equals 1. -4 doesn't equal 1. So that's no solution. Okay. If you get an untrue statement, that's what's going to happen. Okay. If you lose the variable and you get an untrue, that's what goes. So let's look at what happens if we were to rearrange that -x plus, minus a y equals 1. Let's see, if we add x, got -y equals x plus 1, and then we divide by a negative everybody, you get y equals -x minus 1. And look at our slopes, this slope, that slope, same slope, but different y-intercepts, +4, -1, no solution. Okay, so you can do that rearrange and look for it, or you can do the plug-in and see what mathematically you get. So let's try this one. We got, that's a highlighter, we need a pen. We've got what y is. Y is right here, so 2x minus 2 times something equals 16. And we're just going to plug this whole thing right in there, x minus 8. -2 times x, -2x, -2 times -8 is positive 2 times 8. It's not 8, it's 16. 2x minus 2x goes 0. 16 equals 16. It does, but there's no variable left. We just get a true statement. And so when the variable eliminates and we get a true statement, that's infinity. And let's check what happens. If we do 2x minus 2y equals 16, we minus 2x. Negative 2y equals negative 2x plus 16. We divide by negative 2. Y equals x minus 8. Same exact equations. Same equation means same line, means infinity. Okay, substitution that requires isolation. If they don't give you, like we just had in all of these, one of the equations where y or x is equal to everything else on the other side, the first step you have to do to solve a system by substitution is look for an equation that is solved for x and y. But sometimes you need to rearrange. So let's just do a little rearrange here. This one says solve for y. So we want to get this part by itself. So that means that I need to move this. So that's subtract 2x. Y equals negative 2x plus 5. It's just getting it in slope-intercept form. Okay. But we can also, and I'll do it in a different color here. Let's pick green. Solve for x. Get that by itself instead. And the reason that I'd pick one over the other, in this solve for y instance right here, the reason I'd pick to solve for y and get it by itself is because it's a single. There's one y. So I can take everything on the other side and plug it in for y in the other one, no matter how much y there is. In this second one with the green, I would pick the x to solve for because there's one x. And I'm going to move the y. So x equals 4y plus 7. And then I take this whole thing and I'm going to plug it into whatever equation because I got 1x by itself. Now if they both have numbers by them, I'd look at the other equation. See if there's a single variable. If they neither of them have one, then I don't know, pick the one that's easier to solve for. So let's have a look here. Oh, there they are. Look at that. Negative 3x plus y equals 8 and 8x minus 3y equals negative 19. I'm going to choose this equation and I'm going to choose to solve for this variable because it's the least amount of work that I have to do. So negative 3x plus y equals 8. Add 3x to both sides. So y equals 3x plus 8. I'm going to take that whole thing and I'm going to plug it in for y in the other equation. You can't plug it back into itself. So this is the one where you got to be a little particular. So we're going to go 8x minus 3 times some stuff equals negative 19. Everything's the same except I'm just going to put what y is equal to from the other equation. So 3x plus 8. Bring down my 8x and simplify. Negative 3 times 3x is negative 9x. Negative 3 times 8 is negative 24 equals negative 19. 8x minus 9x is negative x minus 24 equals negative 19. Yeah, sure, why not? Add 24. Negative x equals, let's see, from 19 to 24, it's going to be positive. From 19 to 24, 1 to 20, and 4 more, so it's going to be a 5. And then we divide by negative. Okay, so x equals negative 5. All right, so if I'm looking for somewhere to put my stuff, my x is negative 5. Now I'm going to take that, I'm going to plug it back in over here, the original equation that I started with. Don't plug it back into itself. I mean, you could, but there's more work in that equation. This one's already set up to tell me what y equals. I just do 3 times, stick in the negative 5 for x. Y equals negative 15 plus 8, so y equals negative 7. There's my answer. Remember, a solution to a system is going to be a coordinate system of some sort. 2 variables is 2 coordinates. When we get the Algebra 2 version, we do 3 variables, it'll be 3 coordinates. If you did more, it'd be more. All right, so I'll let you give this second one a try here, see which variable you pick. There's multiple options, but try to find the one with the least work. Save yourself some steps. Good luck. Come back after the pause. All right, let's look. I'm going to pick that. because it's 1y by itself and it's already positive. So 4x plus y equals 1 minus 4x. So y equals negative 4x plus 1. This is what I'm going to plug in for y into this equation. So negative x minus 2 times negative 4x plus 1 equals negative 16. I just plugged it in for the y. We're behind the 2. Let's do the distribute. Negative x stays. Negative 2 times negative 4x is positive 8x. Negative 2 times 1 is negative 2. It's negative 16. Negative x and 8x is, I don't know why that happened. 7x minus 2 equals negative 16. Let's add 2. 7x equals negative 14. Divide by 7. X equals negative 2. Negative 2. We just need the y part. Y equals negative 4x times negative 2 plus a 1. Y equals negative times negative is positive. 4 times 2 is 8 plus 1. So y equals 9. That's how that one works. We've got more examples. Okay, give these two a try. See what happens when you come back. All right, here we go. We're going to give them a go. I would solve for the y. It's going to be the least amount of moves that I have to do. So I got 5x minus y equals 6. Now, instead of subtracting 5x and dividing by a negative 1, which is a way you could do this, I'm going to say plus y. 5x equals y plus 6, and I'm going to subtract 6. 5x minus 6 equals y. Just to show you that it doesn't matter which side the variable ends up on, as long as you do the math right, do the same thing to both sides, it's going to be equal. Now this is what I plug in for y in the other equation. Okay, so 2x plus 4 times something equals negative 2. And we're going to plug in that 5x minus 6. Substitute. We know that y is equal to 5x minus 6, so where the y was, I put in a 5x minus 6. Let's distribute. 4 times 5x is 20x. 4 times negative 6 is negative 24. Forgot my x. There it is. Negative 2. 2x and 20x is 22x minus 24 equals negative 2. Add 24. I love that these don't come out as fractions. 22x equals 22. Divide by 22. X equals 1. Nice. 1 comma something. Take it, plug it back into the other. 5 times 1 minus 6 equals y. 5 minus 6 equals y, which equals negative 1. Wow. That's a weird looking negative 1. It kind of looks like a crappy 4. So let's try again. Negative 1. I'm going to solve for x in this one because it's the single. So x plus 2y equals negative 18. Move that 2y. X equals negative 2y minus 18. I'm going to plug all of that in for x this time. So 8 times negative 2y minus 18 minus 7y equals 17. To solve an equation, you have to get down to one variable. So if you plug it in the wrong place, you'll end up with 2 different variables in the equation and you're stuck again. So make sure you plug it in the right place. We solve for x, we plug it in for x. 8 times negative 2y is negative 16y. 8 times negative 18 is going to be negative. Let's see, 8 times 10 is 80, and 8 times 8 is 64. So if we take 20 off of the 60 and add it to the 80, that's 100. And then we had 44 left, so that should be 144 minus 7y equals 17. Like terms, get back to yellow. The y's are like each other. They're both negative, so they're going to combine. It's like add negative 7. So negative 16 and 7. 4 off of the 7 makes 20. There's 3 left, so 23y minus 144 equals 17. Add 144. 44. Negative 23y equals 7 and 4 is 11. 1, 2, 3, 4, 5, 6. 161 divided by negative 23. Let's see. Y equals 161 divided by, it's going to be negative. Let's put that on there already. 23. I don't know, 7 times. 7 times 3 is 21. 7 times 2 is 14, 15, 16. Yep, 7 times. So we got the y part is negative 7. Remember, that's the y one this time, so we got to put it at the back. And then we got to plug that negative 7 in over here for that x. X equals negative 2 times negative 7 minus 18. X equals negative is positive. 2 times 7 is 14 minus 18. 14 minus 18, negative 4. Wow. Boom. More of the same. More of the same. Let's look at the next two just in case. They also look very nice. These are all substitutionable easily because they have at least one variable that is only a single. So give all 4 of these last bits a try, and then when you come back, let's see what you get. So pause and try. Okay, here we go. I'm going to go for the x. X minus 7y. I bet there's supposed to be an equal sign on here somewhere. This one looks like a typo. Yep, it's a typo. So if you got stuck, it's a good guess that this went here because they're the same key on the keyboard, equals and plus. If you push shift, you get the wrong thing. So let's do that. 22, add 7y, x equals 7y plus 22. So we know what x is. So 3 times something plus 2y equals 20. Plug in 7y plus 22. 3 times 7, 21y. 3 times 22, 66. Plus 2y equals 20. Like terms, they're both y's. I got 21 y's and I got 2 y's. That means I got 23 y's. Plus 66 equals 20. Move that 66. 23y equals negative 46. Yep. Divide by 23. Y equals negative. It goes 2 times. Remember, it's the y, so it goes for negative 2. X equals 7 times negative 2 plus 22. X equals negative 14 plus 22. 6, 7, 8. That'll be 8. Ah, interesting. Now, this one, I've got x as a single and I got y as a single. And it doesn't matter which one I solve for because they're both positive now. So, I don't know. Solve for y. Plug in for that. So x plus y equals negative 12 minus y. X equals negative y minus 12. So 8 times, let's see, negative y minus 12. That's what we're plugging in for x. Minus 7y equals negative 21. Negative, why did I do that? Negative 8y. Nope, still negative because 8 times negative, positive 8, so negative 8 times 12, 80 plus 16, 96, minus 7y equals negative 21. I may have chosen the way that is more math. Negative 8y, negative 7y gets more negative. So that's negative 15y minus 96 equals negative 21. Let's add 96. So negative 15y equals, if we go down 1, it's 95. And if we go down 20 from there, you get 75. Which is good because that divides by 15. Y equals negative. Let's see, 2 times is 30. 3 times is 45. 4 times is 60. 5 times would be 75. So the y part is negative 5. I'm going to plug it in. X equals negative times something minus 12. Plug in negative 5. x equals 5 minus 12, x equals negative 7. Last two, let's see what happens here. All right, hopefully this works out. Okay, I'm going to solve for y. 3x plus y equals negative 14 minus the 3x. Y equals negative 3x minus 14. So that's what I'm going to plug in here. So 9x plus 3 times something equals negative 42. And I'm plugging in negative 3x minus 14. That becomes 9x stays. 3 times negative 3 is negative 9x. 3 times negative 14 is negative. 3 times 10 is 40. 3 times 4 is 12, which makes 42. Interesting. I see what's going to happen here. 0. Negative 42 is negative 42. That is true. If it's true like that and I lost my variable, that means that they are all the same. So, infinity. In this last one, I'm going to solve for x. So x minus 4y equals negative 8. Add 4y. X equals 4y minus 8. And I'm going to plug that in for the x. 3 times something minus 12y equals negative 6. 4y minus 8. 12y. Negative 24 minus 12y equals negative 6. 12y minus 12y cancels. Negative 24 equals negative 6. No, it doesn't. That's an So, no, not equal. So there's no solution. That's substitution. It's not my favorite way to solve, but when you got one variable equals stuff and you can simply easily plug it in, that's the way I would do it. Good luck on your